Hey guys, so today we're in section 7.4, the other trigonometric functions. And this lecture should be pretty short because we've already talked about most of what's in this section in the previous section. So to start this section off, I'm pulling the table from the previous lecture where we created a table for sine, cosine, tangent, cosecant, secant, and cotangent, and all of their values from 0 to 90 degrees on the unit circle. But one thing we're going to learn is that all of the other trig functions, aside from sine and cosine, so tangent, cosecant, secant, and cotangent, really are just sine and cosine rearranged. So mathematicians came up with tangent, cosecant, secant, and cotangent because they didn't want to keep having to say sine over cosine or cosine over sine. So it's kind of a thing of just a little bit of laziness more so than anything else. So what do I mean by that? Well, I proved it in the last lecture, but essentially what we showed was that tangent of theta is really just sine of theta over cosine of theta. And so tangent is really just a proportion of sine over cosine. And because cotangent of theta is just tangent flipped, cotangent of theta is just cosine of theta over sine of theta. So it's this fraction, and rather than having to say sine over cosine or write sine over cosine or cosine over sine every time, they just simply called these things different functions, tangent, just quicker. Likewise, cosecant, go and write the whole thing here. Cosecant of theta is just 1 over sine theta. And secant of theta is just 1 over cosine theta. So if you know the values of the table for sine and cosine, so if you really just, let's say, memorize, for lack of a better word, if you memorize the values for sine and cosine, you can build the rest of the table yourself. And even less if you just know the values of either sine or cosine. So let's say you memorize the values of sine from 0 to 90. Well, what is cosine? It's just sine in the opposite direction. So look, 1 is last here for sine. It's the first one for cosine. Square root of 3 over 2 is the second last one. Well, it's the second one for cosine. So you can kind of see how they're just doing things in the opposite order. So if you either figure out sine or cosine, then you know the other trig function, and then you can build all of the rest of the table yourself. So eventually, it'll be easier for you to just memorize the values than it will be to build the table this way. But if in a pinch you forget, well, you can build the table just knowing at least either all of sine or all of cosine. So in this lecture, we're really just going to do a couple examples, and then we'll kind of call it there. So for the first example, we have find sine of t, cosine of t, tangent of t, secant of t, cosecant of t, and cotangent of t when t is equal to pi over 6. Okay, well, so, we have the table for all of this, but let's just assume that we don't. So how would we do this? Well, if we remember that sine of pi over 6 is equal to 1/2, and cosine of pi over 6 is equal to square root of 3 over 2. So once again, just knowing sine and cosine, well, then we know tangent of pi over 6 is equal to sine of pi over 6 over cosine of pi over 6. And since we know the values for sine and cosine, we're able to replace tangent with sine over cosine with their values. And then once again, we're dividing fractions, so we prefer to multiply by the reciprocal or the fraction flip. The 2's cancel out. We get 1 over square root 3. And then because you might not like improper radicals, you can multiply the bottom and top by square root of 3 and end up with square root of 3 over 3, which is our proper radical form. And if we go back to our table, you can see that it in fact checks out because that's what we got the last time we did it. So, but we'll go ahead and go through the rest of these. So cotangent of theta, cotangent of pi over 6. Cotangent is just a flip of tangent, which is cosine of pi over 6 over sine of pi over 6. Also cosine is square root of 3 over 2. Sine is 1/2. Square root of 3 over 2 divided by 1/2. We don't like to divide fractions. We'd rather multiply by the reciprocal. Here the 2's cancel out, giving us just the square root of 3 over 1, which is just the square root of 3. Cool. So then let's do secant. Secant of pi over 6, that's equal to 1 over cosine of theta. Excuse me, not theta, but pi over 6. And that's equal to 1 divided by the square root of 3 over 2. So we don't like to divide fractions. We'd rather multiply by the reciprocal. And so you might be saying, well, 1 isn't a fraction, but every whole number is a fraction. Just write it over 1. And so we have 1 over 1 times 2 over the square root of 3. And so we just end up with 2 over square root 3, but we don't like radicals on the bottom, so we multiply by square root of 3 on top and bottom. We get 2 square root 3 over 3. And then finally, cosecant of pi over 6, that's just equal to 1 over sine of pi over 6. And sine of pi over 6 is 1/2, so we get 1 divided by 1/2. 1 divided by 1/2. Well, we need to make 1 a fraction, so put it over 1. And then so we get 1 times the flip. So 2 times 1 is 2, 1 times 1 is 1, or just 2. Cool, so here are answers for all 6 trig functions. All right, moving on to the next example. It says, use reference angles to find all 6 trig functions of negative 5 pi over 6. So what they want us to find is sine of negative 5 pi over 6 and cosine of 5 pi over 6 and all that. So let's first draw our unit circle really quickly. All right, and so remember that if we're going counterclockwise, our angles are positive, but if we go clockwise, our angles are negative. So since it's negative 5 pi over 6, we're going to start at 0 and we're going to go negative. And so just to quickly sketch our unit circle, recall we have the bisector line or the 45 degree that goes like that. And then we have the two 30 and 60 degree angles as well. Okay. And so going positive, we would have pi over 6 here. Let me erase this arrow. Pi over 4, pi over 3, right? And this is pi over 2. And you could change these to their degree variance if you feel more comfortable doing that. But since we're going in the negative direction, it's going to be the same thing. It's just going to be negatives instead. So we're going to have negative, 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 And so this is negative pi over 6 because it's 30 degrees away from 0, just like regular pi over 6 is. Negative pi over 4. And then negative pi over 3. And so remember that this triangle, so let me do it in green. This triangle here, the triangle in green and the triangle in red are essentially the same triangle. They're just flipped. And so all that we really need to worry about is the positivity and negativity of cosine and sine. And remember that the ordered pair is x comma y, and we said last time that we think of cosine as x and sine as y. So to find sine of negative 5 pi over 6, well, we need to go all the way to 5 pi over 6, which, since this is pi, so let me write it in white. This is pi, right? That's going this way. That's going halfway around the circle. Well, it just so happens that if we go halfway around the circle the other way, this is also negative pi, right? So, well, let's keep doing our red lines. And so we have negative pi over 3. We have negative pi over 2. And so then we have another 30 degree. We have our 45, our next 30 degree, and we have pi finally. Cool. So this angle here is going to be negative 2 pi over 3. This is going to be negative 3 pi over 4. And this is going to be negative 5 pi over 6. And if you're wondering how I'm figuring that out, well, let me create another unit circle and kind of talk about how I'm able to do that in my head. Let me draw that line again. Cool. So we have two different angles. We basically have 30-degree angles and 45-degree angles on the unit circle. So I'm actually going to create two different unit circles, one for the 30-degree one and one for the 45-degree one. And so here, well, we know this is 0. And for the 45 degrees, or the pi over 4, so pi over 4, this is 45 degrees. This, the way you can think of it, is this is 0 pi over 4, this first angle. And then since the 45s, they cut the quadrants in half, so this is 0 pi over 4. This is 1 pi over 4, or simply pi over 4. Let me make that a little prettier. This is 1 pi over 4, or simply pi over 4. Then another half will take us up here, or 2 pi over 4, or simplified pi over 2, but 2 pi over 4. Another one, 3 pi over 4. Another one, 4 pi over 4, or simply just pi. 5 pi over 4. 6 pi over 4. So 6 pi over 4, or simply simplifying the fraction, 3 pi over 2. 7 pi over 4. And then 8 pi over 4, right? 8 pi over 4, or simply 2 pi. So that's how you can figure out which 45-degree angles, how to figure out the radians, just kind of by counting. And then for the 30-degree ones, we do the same thing. So we just think of this first angle here as 0 pi over 6, okay? So 0 pi over 6, or simply 0 radians. So this would become 1 pi over 6, or simply pi over 6. Then we're not going to go to the middle. We're going to skip that one. I'm going to come up here. This is going to be 2 pi over 6, or simply dividing by 2, pi over 3. 3 pi over 6, or simply just pi over 2 again. So the two angles agree. 4 pi over 6, or simply 2 pi over 3. Skipping the middle again. 5 pi over 6. 6 pi over 6, or just pi. 7 pi over 6. Skip the middle. 8 pi over 6, or 4 pi over 3. 9 pi over 6, or dividing by 3, 3 pi over 2. 10 pi over 6, or dividing by 2, 5 pi over 3. And then skip the middle, 11 pi over 6. And then finally, we get 0 or 12 pi over 6, or simply 2 pi. Okay? That's how I'm kind of coming up with these angles quickly. So since we're looking for sine of 5 pi over 6, but negative, we're trying to find the height and the base of this triangle here. Right? Remember that sine we said is kind of like the height of the triangle, or this side, and the cosine of negative 5 pi over 6 would be the base of the triangle, or this side. So, well, luckily for us, notice not only is the first green triangle, and I'll circle it here, this first green triangle and this red triangle, the same triangle, just kind of flipped across the x-axis, but it also is the same triangle here, right? They're just kind of moved around. And so the height of this triangle is going to be the same height of this triangle. The only thing we have to be careful of is, well, in the first quadrant, both x and y are positive, so both cosine and sine are positive. But what about in the third quadrant? Well, they're both negative. So sine of 5 pi over 6 is the same value of sine of pi over 6, which we just did the problem for, so we already know that's 1/2. But the thing is, because it's in the third quadrant, the value must be negative. Sine is negative, right? The y is negative in the third quadrant. And likewise, cosine of negative 5 pi over 6, okay? That value we just did above, so I'll just scroll up so you can see it, right? Pi over 6, that's square root of 3 over 2. So we know the height of the green triangle here is square root of 3 over 2. So this is the same as cosine of pi over 6, but well, cosine is also negative in the third quadrant, so it's going to be, well, square root of 3 over 2, but negative this time. Okay? And to find the rest of our trig functions, we're just going to use sine and cosine and do exactly what we did in the last problem. So I'm going to go to a new page. So we have sine of negative 5 pi over 6. That's going to be equal to just negative 1 times the value of sine of pi over 6, or in this case, negative 1/2. And cosine of negative 5 pi over 6, that's going to be equal to negative 1 times cosine of pi over 6, which is equal to negative square root of 3 over 2. And it's not because the angle is negative. It has nothing to do with that. It's just that the triangle in the first quadrant in 5 pi over 6 is here, and with negative 5 pi over 6, it's in the third quadrant. So it's the same triangle, just orientated differently. So what we had here was positive for the height and for the base, because x and y are both positive in the first quadrant. But in the third quadrant, where our angle negative 5 pi over 6 is. Remember, we have to rotate clockwise. The base and the height are both negative because x to the left is negative and y down is negative. Okay, so then if we want to figure out tangent of negative 5 pi over 6, well, tangent is sine of negative 5 pi over 6 over cosine of negative 5 pi over 6. And so since both of these are negative, right, we have negative 1/2 over negative square root of 3 over 2. The negatives cancel, right? Negative divided by negative or negative times negative is going to be a positive. And so we're going to get square root of 3 over 3. And I'm just saving you, showing you the algebra again because we did it in the previous problem. And so cotangent of negative 5 pi over 6, well, that's just going to be this fraction flipped. So cosine of negative 5 pi over 6 over sine of negative 5 pi over 6. So we get the square root of 3 over 2, but negative, and sine, which is negative 1/2. And so the 2's on the bottom cancel, and we just get the negatives cancel as well. Negative divided by negative positive. So we just get positive square root of 3. And that's only because both sine and cosine are negative. And then we have secant of negative 5 pi over 6, which is equal to 1 over cosine of negative 5 pi over 6. And so we have that value over there, 1 over the square root of 3 over 2, but negative. And so we're just going to end up with 2 square root of 3 over 3, but negative. And this is just doing algebra. Just kind of skipping that for this guy because we just did it in the previous problem. And so negative cosecant of negative 5 pi over 6 is just 1 over sine of negative 5 pi over 6. But remember this value here, the bottom, we have it. We've already done the work there. Excuse me. We know that sine of negative 5 pi over 6 is equal to negative 1/2. And so we can just plug in negative 1/2 down here. And so that's going to be 1 divided by negative 1/2. Change the 1 into a fraction. We don't like to divide by fractions. We'd rather multiply by the reciprocal. And so 1 times negative 2, it's negative 2 over 1, which is just negative 2. Cool, so here are all our solutions for the 6 trig functions of of negative 5 pi over 6. Okay, so in the next problem, they want us to simplify secant of t over tangent of t using these simple identities that we came up with. And what simple identities are they talking about? Well, just that tangent of theta is equal to sine over cosine. Cotangent of theta is equal to cosine over sine. Secant of theta being equal to 1 over cosine of theta, and cosecant of theta equal 1 over sine of theta. And so with the secant of theta part, so I'm going to resize this stuff a little bit. So we have secant of t over tangent of t. And we can rewrite secant as 1 over cosine of t. And we can rewrite tangent of t as sine over t over cosine of t. And so we can write this as 1 over cosine of t divided by sine over t over cosine of t. So that's going to give us dividing two fractions, which we don't like to do. We like to multiply by the reciprocal. And I'm only saying this repeatedly so much, so eventually it becomes easy for you to think about. So now we can cancel our cosines, and we just end up with 1 over sine of t. But notice that this is also one of our identities. So rather than keeping it as a fraction, well, we can replace this with cosecant of t. And there is our final answer for this problem. Okay. So also in the last section, we started with the formula for a circle, for the unit circle in algebraic terms, and then we eventually said, well, we could change this so in trig terms, and we came up with this formula. And actually, what we can also do once we have this trig identity, if we divide everything here by sine squared, this gives us a new identity, because now we have cosine over sine squared plus, well, sine squared over sine squared is 1, and 1 over sine theta squared. And notice this first squared symbol is really just a cotangent. So it becomes cotangent squared of theta plus 1 is equal to, and this term right here is just cosecant. So this becomes cosecant squared theta. And if we were to take our trig unit circle and this time divide it by cosine squared of theta, well, we end up with, well, this is 1, because cosine squared divided by cosine. This becomes sine of theta over cosine of theta squared is equal to 1 over cosine theta squared, which is 1 plus, well, that's tangent theta squared, and then 1 over cosine, well, that is secant theta, and since we have the square. So this is just a quick way of showing that we have 3 ways of talking about the unit circle in trig, and these are called the Pythagorean identities because they are a squared plus b squared equals c squared, except for triangles and circles that are of radius 1. So these will be important, and they'll come up a lot later. So I'm just going to write them down here. So these are good to remember. So maybe put a star by them in your notes. And we're going to use these Pythagorean identities to solve one more example. All right, and for the last example for this section, it says if cosine of t is equal to 12 over 13 and t is in quadrant 4, find the values of the other trig functions. So in this problem, we're going to be using the Pythagorean identities we just went over. Since we have cosine, well, the 3 Pythagorean identities we have are sine squared theta plus cosine squared theta is equal to 1. We have tangent squared theta plus 1 is equal to secant squared theta. And then we have cotangent squared theta plus 1 is equal to cosecant squared theta. And so since they give us the value of cosine, well, the only Pythagorean identity that has cosine is the first one, so this is the one we're going to use for our problem. And so since they're telling us that cosine of t is 12 over 13, And they also tell us that t is in quadrant 4. That means we're going to be in this quadrant here. And so we're just going to draw a triangle. We don't really know what this angle is, so there's no point in worrying about it too much. But essentially what we're looking for is the base of the triangle and the height of the triangle. And because remember that this point here is an x comma y, or in trig terms a cosine theta, sine theta, and we already know cosine of t is 12 over 13, we already have this part of the ordered pair. And so really what we're looking for is what is sine theta equal to. And by using this trig identity here, so we have sine squared, right? We don't know what sine is. Sine squared of theta plus cosine squared, but cosine squared, we already know cosine is equal to 12 over 13. 12 over 13 squared is equal to 1. And so, well, sine squared theta, and so we get 144 over 169 is equal to 1. And we're going to get our numbers on the same side and leave sine by itself. So sine squared theta is equal to 1 minus 144 over 169. And because we're trying to subtract fractions, we need common denominators. So this is 169 over 169 minus 144 over 169, which is going to give us 25 over 169. And actually I'll just, rather than bringing it to a new page, just resize it and move it around a little bit. Probably should have chosen a different color to do this in, but I'll just put a line. Okay. And then now, since we have sine squared, we need to take the square root of both sides. So that leaves us with sine squared theta equals take the square root, that gives us sine of theta is equal to plus or minus 5 over 13, because 13 times 13 is 169, and 5 times 5 is 25. Okay, so well, we know sine of theta, it's either equal to, so I'll do this in white here, we know sine of theta is either equal to 5 over 13, or sine of theta is equal to negative 5 over 13. Okay, so how do we figure out which one it is? Well, notice cosine of theta is positive. Okay, well, where is cosine positive? Cosine is positive either in quadrant 1, because remember cosine is like x, and y is like sine, or sine is like y. And cosine is positive, which means, well, whether we had the triangle in the first or fourth quadrant, they would kind of share this same side of the triangle, right? This part we've marked here. But because they tell us specifically that we're in the fourth quadrant, right? We're in quadrant 4, all we really have to think about is sine positive or negative in the fourth quadrant, or is y negative or positive in the fourth quadrant? And because we're below the x-axis, we know that y is negative in the fourth quadrant. So that tells us that the answer is sine of theta equals negative 5/13 and not positive 5/13. Cool. So we have, let's go to a new page. We know that cosine of t is equal to 12/13. Sine of t, say t, and I switched it to theta. Yeah, that's okay. It's just a variable. Negative 5 over 13. And they want us to find all the other trig functions. So tangent of t, remember that's just sine over cosine. And so the 13s are going to cancel. We're going to get negative 5 over 12. And then, not cosine, excuse me. Cotangent of t is just going to be tangent flipped. So we have negative 5 12. This one's going to be negative 12 over 5. Secant of t, that's just cosine flipped. So that's just going to be 13 over 12. And cosecant of t is just going to be sine flipped, so negative 13 over 5. And that is all of our trig functions found. Okay. And I think that just about does it for section 7.4. And we'll be covering section 8.1, I believe, in the next section, because this is the end of chapter 7. And so we're going to start talking about the graphs of these trig functions. If you have any questions, go ahead and let me know. And I'll see you in the next one.